Yes, very good morning to everyone. Okay, am I audible in both classes? Can you people type it in the chat? Yes. What about in classroom 2? Yes, okay, fine. Before getting into today's topic, we will see what are the things we have discussed in the previous session. Okay. In the previous session, we have told the features of Intel 8051 microcontroller. What about the word size of 8051 microcontroller? Quick answer பண்ணுங்க. Yes. What about the word size of Intel 8051 microcontroller? Yes, very good. 8-bit. Fine. Then, what about the size of on-chip ROM and RAM memory? Yes. What about the size of on-chip ROM and RAM? Yes, very good, Dixon. 4 KB of ROM and 128 byte of RAM memory. Okay. What about the external memory accessing? What's the maximum size we can interface externally? What is the maximum size of memory? Yes, very good, 64 KB. Fine. Then internally, what are the components it has? என்னென்ன IO device இருக்கும்னு பார்த்தோம்ப்பா. Apart from this, what about the other things present inside the 8051 microcontroller? Yes. I'm waiting for your response. See, on-chip peripheral வேற என்னென்னலாம் இருக்குன்னு சொன்னோம்ப்பா 8051 microcontroller. Also, we have discussed about the function block diagram, correct? Function block diagram பார்த்தே சொல்ல முடியும். About the other things, yes, very good. CPU core it has, fine. Okay, IO ports. How many IO ports it has? How many IO ports it has? Yes, very good. 4 IO ports, fine. What about the size of each IO port? 8-bit, very good. How many timers we had? How many timers we had? Yes, very good. 2 timers. Yes, 2 16-bit timer per counter. Fine, very good. What about the serial communication, whether it is half duplex or full duplex? Yes, very good. Fine. What about the number of interrupts it can handle? The total number of interrupts handled by 8051. Yes, very good. 5. Very good. Okay. Then we have discussed about the functional block diagram of 8051 microcontroller. Fine. Then we have discussed about the signals of 8051 microcontroller. What are the signals we are having in 8051? What about the purpose of each signal that we have discussed? Fine. Then we have introduced how the memory is organized in 8051. Fine. So now we are going to continue with memory organization. Fine. So already we have discussed this in the previous class. Fine. To have some continuation, I'm going to recap it one more time. Fine. So on-chip ROM, we are having 4 KB of memory, then internal RAM of 128 byte. Fine. We have to understand one thing. When I say on-chip ROM, what about the size of address? On-chip program memory அப்படின்னு சொன்னோம்னா அதனோட address bit எத்தனை bit இருக்கு? What about the address bit for on-chip ROM? On seeing this, you can say 0000H to 0FFFH. How many bit? This one. How many bit address? Danya, whether it is 8-bit? Yes, very good, Dixon. 16-bit address for the internal program memory. Fine. What about the address bit size of internal RAM to address the internal RAM? On-chip RAM. Yes, 8-bit address. Fine. Is it clear to all of you? What about the address bit, number of address bit for addressing the external memory, whether it is ROM or RAM? See, external program memory or data memory, when I say the address size is, the size of the address is 16-bit. Fine. When I am addressing the internal ROM, the size of the address must be 16, whereas for internal RAM, it is 8-bit only. Fine. So what about the other address from 80 to FF? Even though we say 8-bit address, 128 bytes only we are having as a internal RAM memory. Fine. What about the remaining address? It is mapped to where? For internal special function register. We have 21 special function registers in Intel 8051. Those are mapped within this address space. Fine. Okay. So 8051 microcontroller can address a maximum of 64 KB of external program memory and 64 KB of external data memory. Correct? The program memory can be selected with the hardware pin. If EA bar equal to 0 means the total program will be executed from the external ROM alone. Fine. If EA bar is equal to 1 means 4 KB, up to 4 KB, it will execute the program from internal ROM. Then beyond that, automatically it will execute the program. It will try to execute the program from the external ROM. Fine. Kindly note down the address space. So either the 64 KB of program is only from external ROM or 4 KB from internal ROM and 60 KB from external ROM. Fine. What I am telling is about the program memory. Fine. Do you people understand how to select the internal or external ROM? Using the hardware pin EA bar. What EA stands for? What EA stands for? The pin EA bar. What EA stands for? Kindly type it in the chat. The previous class we have discussed about the signals. Yes, very good. External access enable signal. Yes, very good. If this pin is 0, then the 8051 will fetch the program, the whole program from the external ROM only. It won't consider the internal ROM. Fine. If EA bar is equal to 1 means it will execute the program from internal ROM. Okay. If the program size exceeds beyond 4 KB, automatically it goes for external ROM only. Fine. Then coming to the RAM. Both internal RAM of 128 byte and external RAM of 64 KB can be accessed by 8051 at any time. Whereas in the case of program memory at any point of time, totally it can access only 64 kilobyte. Whereas in the case of RAM, it can access 128 byte internal RAM as well as the external RAM. Fine. It can be decided by the hardware or software. Which one is going to decide whether we are going to access the internal RAM or external RAM? Whether we have any hardware pins? Whether we have any hardware pins to choose the internal RAM or external RAM? Definitely no. For ROM only we are having EA bar pin. Regarding RAM, your instruction, whatever the instruction we are writing, if it contains MOVX, if the instruction contains the word MOVX, that means external data transfer from the RAM memory, external data transfer between the RAM and the CPU, correct? So for that we have two dedicated instructions, MOVX space A comma at DPTR. That means from external memory to accumulator. Similarly, MOVX at DPTR comma A. So this two instruction can be used to access the external data memory. Fine. This is the only way to access the external data memory. Fine. So உங்களோட program நீங்க எழுதி இருக்கிறதுல MOVX அப்படிங்கிற instruction, if it is getting executed, the 8051 microcontroller try to access the data from the external RAM. That's it. Fine. When I say external RAM, what about the size of address bit? Just now you have typed. External memory அப்படின்னு சொன்னாலே அட்ரஸோட சைஸ் என்னப்பா? 16 bit. 16 bit is the correct thing. The memory size is 64 KB. Okay, the number of address bit to address the memory location is 16 bit only. Fine. Then coming to the internal RAM memory, how it is organized. Okay, before getting into that, you can see this. Okay, you are having different distinguishing signal to read the code from external ROM. Fine. Here you can see EA bar equal to 0 means what? The whole 64 KB starting from 00002 FF, it is from the external ROM only. Fine. Yes? Is this diagram is visible to all of you? On seeing this, what you are inferring? Regarding the program memory, okay, if EA bar equal to 0, the entire 64 KB address, sorry, the entire 64 KB memory is from the external memory only. Fine. The microcontroller will execute the entire program from the external memory only. It won't consider the internal ROM. Fine. If EA bar equal to 1 means it will consider the internal ROM, okay, up to 4 KB. Beyond that, it will access the external ROM only. Fine. What about the signal we used to read? What about the signal the 8051 microcontroller used to read? The code, to read the code memory, which signal is used? See, we are having two memory, yes, 64 KB of external ROM, 64 KB of external RAM. Fine. For reading the program memory, okay, we are having PSEN bar signal. What is the abbreviation for this signal? PSEN stands for what? Yes. Whenever your 8051 microcontroller is executing the program from external memory, it has to read the instruction from the external ROM, correct? For that, we are having the signal PSEN bar. Yes, very good. Program store enable signal. Okay. So, whenever your 8051 microcontroller is fetching the program from external memory, external program memory, this PSEN bar signal is used as a read signal. Fine. Whereas in the case of data memory, the internal memory is of 128 byte. Fine. 00 to 7F, then 7F to F, sorry, 80 to FF is mapped for SFR. Fine. 8-bit address we have used for internal RAM. Fine. Whereas in the case of external RAM, the 64 KB can be accessed with the help of this signal RD bar and WR bar. Fine. MOVX instruction use panni when you are trying to read a data from external RAM to accumulator, read bar signal will be activated. When we are writing a data to the external RAM memory, write bar signal can be used. Is it clear to all of you? See, 64 KB ROM RAM, rendukume address common da, correct? Which is going to distinguish whether we are going to read the program memory or we are going to read the data memory. Which signal differentiate? In the case of code memory, it is PSEN bar. In the case of data memory, it is read bar. Is it clear to all of you? Is it clear to all of you? Yes or no? Program memory நம்ம access பண்ண போறோம் அப்படின்னா, sorry, if your microcontroller is accessing the external program memory, so PSEN bar signal can be used. Fine. When it is accessing the external data memory, okay, if it is a read operation, RD bar signal is used. Then if it is a write operation, WR bar signal is used. Fine. Is it clear? Yes. Fine. So now we will go with the internal RAM memory organization. Fine. So RAM memory internal how it is organized, that we are going to see in this slide. Fine. So 00 to 7F, it is mapped for the 128 byte RAM memory location. Then 80 to FF, it is mapped for SFRs, correct? That we have already discussed. Fine. In some of the microcontrollers from 8051 family, okay, generally we will say 51 family microcontroller. Okay, so 8051 is one among the family. Fine. In higher version of 8051 microcontroller, you will be having another 128 byte RAM that can be addressed by indirect addressing only. Fine. Accessible by direct addressing only. That means SFRs alla on the direct addressing concept use பண்ணுவோம். When we are addressing the another 128 byte available in the higher version of 51 family microcontroller, okay, that can be done by indirect addressing only. Fine. Whereas this can be addressed both by direct as well as indirect addressing. Fine. As of now, don't worry about this upper 128 byte RAM. It is not available in 51 microcontroller. Intel 8051 la kadiyadu. Fine. Don't worry about this. Fine. So totally we are having 128 byte RAM location. Then another 128 byte address space is mapped for SFR. Fine. So the internal RAM memory is 128 byte. Okay, and SFR can be accessed by 8-bit address. Okay, here it is 82FF. Sorry, it's not 002FF. Sorry. Wait a minute. Wait a minute. Number 8. It is 82FF. Sorry. So the internal RAM memory of 128 byte are mapped to address. Wait a minute. SFR. Okay. So internal RAM memory of 128 byte and SFR can be accessed by 8-bit address. The internal SFRs are mapped to address from. Sorry, I think here it is correct. It's correct only. Sorry. Okay, on seeing this picture, you can see. Okay, so 128 byte RAM is from 00 to 7F. Okay, then the SFR is mapped from 80 to FF. Totally, we are having 256 locations. Out of that, lower 128 byte is for RAM and upper 128 byte is for SFRs. Fine. Okay. Now coming to the 128 byte RAM. This 128 byte RAM is further divided into 3 areas. Okay. So like this, from 00 to 1FH. Yes, from 00 to 1FH. This memory, it is utilized for registers. Okay, that we call it as register banks. Totally, we are having 4 banks of registers available here. Then another 16 byte. That means from 20 to 2F, 20H to 2FH. This is bit addressable RAM area. Fine, I will explain in detail about this. Then another memory from 30H to 7FH. It is for general purpose RAM area. That means the total 128 byte memory is divided into 3 sections. Okay, register bank area. Fine, from 00 to 1FH. Then 20H to 2FH. It is bit addressable RAM area. Then the remaining memory space is for utilized for general purpose RAM area. Fine. Coming to register banks. Okay. Here we will be going to have 4 banks of registers. Fine. Each bank is going to have 8 registers named as R0 to R7. Fine. Totally, how many register banks we are having? 4 register bank. Each register bank is going to have 8 registers which are named as from R0, R1, R2, R3, R4, R5, R6, R7. 8 registers are available in each bank. Fine. So totally we are having 4 register bank. So totally in total, how many registers will be having in register bank area? In total, how many registers we will be having in the whole register bank area? Very good. 32 registers. Fine. So each is going to have 8 registers. Each bank is going to have 8 registers. But all the registers in all the registered banks are named with similar naming only, R0 to R7. Fine. So register bank 0 will be having 8 registers from R0 to R7. Then register bank 1, it is going to have another 8 registers. It is also named as R0 to R7. The naming of register in all the banks are similar. Fine. That means whenever the user want to access a register from a registered bank, the bank must be selected. Fine. Kindly note down this. When you are writing program, if you want to use the registers available in bank 2, you have to select the registered bank 2. Then you can use the register naming from R0 to R7. So the registers from bank 2 will be utilized. Fine. Is it clear to all of you? Before accessing any register in the registered bank, that registered bank must be selected initially. By default, registered bank 0 will be selected. Fine. Is it clear to all of you? Is it clear to all of you? Here the 32 byte of RAM memory can be used as a register in 8051 microcontroller program. Fine. How it can be accessed? First you have to select the register bank, then you can use any of the 8 registers from the selected register bank. Fine. Is it clear? At any point of time, if you want to switch between the register bank, you have to select it. Fine. For that, you will be having a register called PSW. In that, we have 2 dedicated bits to select this register banks. Fine. Later, we will discuss about it. As of now, in the 128 byte RAM, the lower 32 bytes are allocated for register banks. The address is from 00 to 1F. So how the address range is for each register bank? 00 to 07, register bank 0. Then 08 to 0F, register bank 1. Then 10H to 17H, register bank 2. Then 18H to 1FH, register bank 3. In that way, the register banks are organized in 8051 microcontroller. Fine. Then it's a very important thing we have to know about this. From the memory location 20H to 2FH. 20H to 2FH. Totally we are having 16 bytes. Fine. So totally we are having 16 memory location, and each memory location it is going to have 8 bits. Correct? So this RAM memory location, each bit can be addressable. Okay. Each bit in this particular RAM location are having unique address. That means bit addressable RAM location. Fine. Generally, this area is used for bit operations. Okay, do you understand what do you mean by bit operation? See, if I say any register in 8085, is it possible to set or reset only that particular bit in the accumulator register? Is it possible? Whether it is accumulator or B register or C register, the whole 8-bit only we are accessing in the 8085 microprocessor, correct? But here in the case of 8051 microcontroller, it is having a bit handling capability that we have discussed earlier. The CPU of 8051 is a Boolean processor. It can handle bit operation, many bit operation instruction, correct? So here, for example, you consider the RAM location 20, it is going to have 8 bit. The LSB of the memory location 20 is assigned with address 00H. Okay, so 8-bit address only we are going to use for addressing each bit. Totally how many bits we are having? On seeing this number of cells, you can tell. 16 memory location, each is going to have 8 bit. Correct? So totally how many bits we are having in this bit addressable RAM area? How many bit location we are having? Can you people type it in the chat? How many bits we are having within this area? 128 bit, very good. 128 bits we are having. How 128 bit? How 128 bit? We are having 16 RAM memory location multiplied by 8 bit in each memory location. Correct? So we will be having 128 bits. Is it clear to all of you? Is it clear to all of you? In total, we are having 128 bits. Is it clear to all of you? Fine. To address this 128 bit, okay, each bit must be having an address, correct? So 128 bit minimum 7 bit address we know, fine. But here also we are using 8 bit address. That means 00H. Fine. This particular bit will be addressed. 01H. This particular bit will be addressed. Fine. Based upon your instruction, based upon the instruction, the microcontroller understand whether it is a bit operation instruction or byte operation instruction. Fine. Instruction only define whether it is bit operation or byte operation. Whenever you are using bit operation instruction, whatever the address you are mentioning, it is a bit address. I think it will be clear to all of you. Totally, we are having 128 bits available in this RAM location. Each bit can be addressed. Each and every bit in this RAM memory location can be addressed. That's why it is called as bit addressable RAM area. Generally, this RAM area can be used for bit operations. When handling bit operation, this particular RAM area can be utilized. Fine. What about the register bank area? This area of RAM location can be used as registers. Is it clear to all of you? What about the remaining bytes? So here we have 32 bytes, here we have 16 bytes. Totally 48 bytes are over. What about the remaining number of bytes? What about the remaining number of bytes? What about the remaining number of bytes? Out of 128, 32 bytes for register bank area and 16 bytes for bit addressable RAM area. What about the remaining number of bytes location we are having? 3027F. That is the address space. How many bytes will be having? No, Dixon. See, from 128, you just subtract 32 minus 16. You will be getting, I think, 80 bytes. Correct? Yes, very good, Andrew. 80 bytes. So 128 bytes, 32 bytes for registered bank, 16 bytes for bit addressable RAM area. So we'll be having a remaining 80 bytes. That we call it as general purpose RAM area or scratch pad area. Fine. Even though we are having 128 byte of RAM memory location, efficient programmer will use this 128 byte as in this way. Fine. 4 register bank which can be used only as a register. Fine. It is not like that. You can also use this register bank area as a RAM memory location. No problem with that. But to write a efficient programming, fine, you must use this particular 32 bytes as a register. Fine. This 16 byte of memory location as a bit addressable RAM area. The remaining 80 bytes you can use it as a normal RAM memory. Fine. That we call it as general purpose RAM area. Fine. It doesn't mean in the register bank area where now the RAM memory location access panna mudiyum. Okay. When we are going for instruction set, you can have a clear idea about this. This 128 byte of memory location is RAM only. Fine. But it can be viewed as 32 registers we are having in the register bank area, which are grouped as 4 bank. Each bank is going to have 8 registers named from R0 to R7. Then this 16 byte can be used as 128 byte bit location. 128 bit location. This entire 16 byte of RAM memory can be utilized as 128 bit locations for bit operations. Fine. The remaining 80 bytes can be used as a general purpose RAM memory. Fine. In this way, the Intel 8051 memory is organized. Internal 8051 RAM memory. Internal RAM memory of 8051 is organized in this way. Is it clear to all of you? Total 128 byte இருக்கு. 3 areas are divide பண்ணிருக்காங்க. Register bank area, bit addressable RAM area, general purpose RAM area. Fine. So register bank area means we are having 4 bank of register. Okay. So each bank it is going to have 8 register. In total we are having 32 register. But each registers in each register bank is going to have similar naming from R0 to R7 only. Fine. So before using any register in the register bank must be selected first. Okay. Fine. I hope it is clear to all of you. Yes, shall we proceed further? Shall we proceed further? Yes. Do you people have any doubt on this? Yes, fine. Okay. So now going for memory mapping of SFR. Fine. So total 00 to 7F. It is assigned for internal RAM memory of 128 byte. The another 128 byte RAM, another 128 address space, address locations is mapped for SFR in this way. Fine. So you can see each box you consider it as a register. Fine. So 80, it is one memory location. Then 81, 82, 83, 84, 85, 86, 87. Fine. So similarly, you will be having another 128 byte. So it is mentioned in terms of byte, not bit. Fine. Is it clear? Okay, now you can see, totally 21 SFRs you can see. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 blocks are highlighted. That means 21 byte address. Okay, here the address mentioned is byte address. It is not bit address. Okay, fine. So out of this 128 byte address, 21 address are mapped for SFRs. Fine. The other spaces are utilized in higher version microcontroller. Okay, there we may have more number of SFR. 21 SFR தாண்டி இருக்கலாம். Fine. Okay. How they are mapped? We can see. You can see 4 register P0, P1, P2, P3. Correct? P0, P1, P2, P3. Can you people judge what about this registers or what purpose it can be used? P0, P1, P2, P3. 4 registers. Okay, this and all we will study later. Fine. So these 4 registers are used for programming the port. We have already studied. We are having 4 ports, port 0, port 1, port 2, port 3. These 4 registers are used for programming the port. Okay, then the register. Fine. TCON, TMOD, TL0, TL1, TH0, TH1. This 6 registers, it is used for programming the timer bar counter. Okay, 216-bit timer bar counter. So to program that timer bar counter, we are having TCON, TMOD, TL0, TL1, TH0, TH1. Fine. To program the serial port, we are having 2 registers, SCON, SBUF. SCON, SBUF. Fine. SCON, SBUF. These 2 registers are used to programming the serial UART. Fine. Then IE, IP. These 2 registers are used for programming the interrupt. Fine. Just you can group in that way so that you can know what are all the SFRs we are having in 82. No need to memorize these 21 SFRs. You just group it. Port program பண்றதுக்கு we are having 4 register P0, P1, P2, P3. Fine. To program the timer bar counter, we are having 6 registers TCON, TMOD, TL0, TL1, TH0, TH1. To programming the serial port, we are having 2 register SCON, SBUF. To programming the interrupt, we have 2 register IE, IP. Fine. To programming the power saving hardware, we have 1 register PCON. Fine. That's all about the registers associated with the IO. What about the other things? What about the other register? You can see SP. Okay, SP, stack pointer register. Fine. DPL, DPH. Combinedly, we call it as DPTR. That we will see later. Fine. Then PSW, it is 1 register, accumulator, and the B register. So these are the registers associated with the CPU. Fine. That we will discuss later. Totally, we are having 21 SFRs which are mapped in the another 128 address. Fine. Starting from 80 to FF. I hope it is clear now. The internal memory, internal RAM memory, we are having 128 byte. It is divided into 3 area: register bank area, bit addressable RAM area, and general purpose RAM area. The another 128 location, address location, it is mapped for SFR. So in that we have only 21 SFRs mapped. The remaining address space are not mapped for anything in Intel 8051. That's it. Fine. So the blue color things what highlighted is for IO port. The yellow are for control SFR. The green are for other SFR. That's it. Okay. Okay, fine. Now we will move to the next slide. So external memory interfacing with 8051. Fine. How to interface external memory, whether it is program memory or data memory, both we are going to discuss. How it can be interfaced with 8051 microcontroller. Okay. Now we will discuss about that. Fine. To interface any memory device, what we need primarily. எனக்கு ஒரு மெமரி டிவைஸை என்னோட ப்ராசஸர் ஆர் கண்ட்ரோலர் கூட கனெக்ட் பண்ணோம் அப்படின்னா டெஃபினட்டா நமக்கு என்ன வேணும்? வாட் வி நீட் போர்ட் பின்ஸ். நோ, 85ல நம்ம என்ன பண்ணோம்? மெமரி டிவைஸ்ல இன்டர்ஃபேஸ் பண்றதுக்கு என்ன யூஸ் பண்ணோம்? Port pins are generally used to interface input output device only. I am speaking about I'm speaking about memory device. To interface memory device, what we need. Of course, here we are going to use only port pins. Okay. But generally what we need to interface memory externally. எப்படி இப்ப மெமரிக்கும் சிபியூக்கு இடையில கம்யூனிகேஷன் வரும். We need some path, correct? What we call it as? Yes, very good, Anthony Surya. Bus. We need address bus and data bus, correct? Here in 8051, to interface the external memory, which two port can be used as address and data bus? Can you people type it in the chat? எந்த ரெண்டு போர்ட் நம்ம வந்து அட்ரஸ் டேட்டா பஸ் யூஸ் பண்ணிக்கலாம்னு படிச்சிருக்கோம். Yes, do you remember? Out of the 4 ports, 2 ports can be used as an address data bus. Yes, very good, Anthony Surya. Port 0 and port 2, fine. Whereas port 2 enna sonnompa, port 2 can be used as a higher order address bus, fine. Whereas port 0 can be used as, I think somebody unmuted.
For Bharat.
Wait a minute.
For Bharat.
I have muted that. Okay. Fine. So port 2, it is used as a higher order address bus. What about port 0? Here in this diagram you can see port 0 is a multiplex lower order address and data bus. Whenever you are interfacing the external memory, whether it is program memory or data memory, okay, you have to use the 2 port as a address and data bus. How it is organized? Like in 8085 microprocessor, here also they have used multiplexing concept. Okay, port 2 carries higher order address, whereas port 0 carries address as well as data. It is multiplexed, fine, time multiplexed, fine. To demultiplex this, which signal we have to use? Can you people type it in the chat? Which signal we have to use to demultiplex the multiplex address data bus? Yes, ALE, fine. So here we have ALE signal, ALE slash PROG bar. ALE slash PROG bar, correct? So here for interfacing the external memory, this signal is used as ALE, fine. So ALE, whenever ALE is high, this particular thing address will be latched here, so it will function as a lower order address line, fine. The output of the latch will act as a lower order address line, fine. Whereas the higher order address line is from port 2. So now the address bus and data bus is ready. Okay, we need one signal to read the code from the external room to 8051. Which signal we have to use? Which signal we have to use? To read the external program memory, which signal can be used? Which signal can be used? PSEN, very good, PSEN bar. Okay, not VPP Dixon, PSEN bar. Okay, so here you can see, here in this diagram you can see. So P2 is connected to the address bus of this memory, then the demultiplexed lower order address is also connected. So 16-bit address for addressing your external program memory, fine. Then here we have the data bus, which is going to be used as a medium to transfer the instruction from the ROM to 8051, fine. Okay, the very important thing you have to see in this diagram, fine, how to configure your 8051 microcontroller so that it will access the program from external ROM. Which pin must be configured? Which hardware pin must be configured so that it will access the program from external ROM? External memory எனக்கு access பண்ணனும் அப்படினா definitely ஒரு pin நம்ம என்ன பண்ணனும்? Low பண்ணனும். Which pin? No Dixon. Very good, Shivakumar. EA bar pin. Yes. Can you see in this diagram? Yes. EA bar pin is grounded. Then only it will access the program from the external ROM. If this pin is connected to VCC, it will access the program from internal ROM up to 4 KB. When it exceeds 4 KB, it will search for external ROM. Fine. Is it clear to all of you? So this picture clearly explains the interfacing of external program memory with your 8051 microcontroller. This is the way you have to connect your external program memory with 8051 microcontroller. Is it clear now? Is it clear now? Yes or no? Yes, fine. Okay, now we are going to see how to interface the external data memory with 8051 microcontroller. Fine. Here you can see in the diagram OE bar out enable. That means in the select panna address data I mean instruction in the signal enable. Whenever PSEN signal goes low, the selected address, the content will be available in the port 0, which is functioning as a data bus. Fine. Okay, now we will discuss about the interfacing of external RAM memory with 8051 microcontroller. This diagram you can see. The same thing we are using. Port 2, it is connected to the address bus of RAM memory. Fine. Again, the demultiplex the address bus. The demultiplex lower order address, it is connected to the lower 16-bit address of the RAM. So totally we are having 16 pins now to address the 64 KB external RAM. Fine. So this port 0 is demultiplexed externally with the help of ALE again. Okay. So this lower order 8 line, then higher order 8 line, combined it is a 16-bit address bus now. Then the demultiplex data bus, it is functioning as a data bus now, which is from port 0. Fine. To read the RAM memory, which signal we need? To read the content from RAM memory, which signal we have to use? Program number read பண்றதுக்கு PSEN bar சொன்னோம், கரெக்ட்டா? To read the RAM memory content, which signal we have to use? If it is program memory, we are using PSEN bar. Program memory la content read பண்றதுக்கு PSEN bar signal we have used to read the external program memory. Fine. To read the external RAM memory, which signal we have to use? On seeing the diagram, you can say two signals we need, as it is read-write memory. For read operation, one signal. For write operation, we have one signal. Can you type it in the chat? What about those signals? Yes, RD bar, WR bar. Whether we have dedicated pin in 8051? Taniya pin irka 8051 la RD bar, WR pin? Yes or no? No. No. No, Shivakumar. Okay, from where this pin comes? RD bar, WR pin. Already I have told you. Port 0 and port 2 is having some alternate function. That's what we have discussed. Correct? Similarly, another port we have to use. No Antony Surya. No IO/M bar. Yes, very good, Vignesh. From port 3. It is from port 3. Correct? Yes, P3.6, P3.7. Those two pins we have told as for read and write signal. Correct? You can see in this diagram from port 3, we are using two pins, one as a RD bar signal, the another one as a write bar signal. That's it. Fine. Now you can understand. Now you can understand. ஒரே ஒரு டவுட் வரலாம். சார் 16-bit அட்ரஸா இருந்தாலும் சரி, டேட்டாவா இருந்தாலும் சரி, ஒரே அட்ரஸ் டேட்டா பஸ் தான் நமக்கு இருக்கு. அப்ப எப்படி டிஃபரன்ஷியேட் ஆகும் ரோமா ரேமான? It is based upon the signal PSEN bar or RD bar. Correct? Program memory la indha instruction read pannona PSEN bar. That's why it is termed as program store enable signal. Fine. Whereas in the case of RAM memory, it is RD bar. So it is distinguishing whether we are reading the content from RAM or not. I hope it is clear now. Yes. Yes or no? See, ரெண்டுமே interfacing almost ஒன்று தான். கரெக்டா? இந்த கண்ட்ரோல் சிக்னல் பாருங்க. இங்க வந்து ரீட் பண்றதுக்கு PSEN பார், இங்க ரீட் பண்றதுக்கு RD பார், ரைட் பண்றதுக்கு WR பார். இங்க என்ன போட்டுருக்காங்க பாருங்க, WE பார், ரைட் எனேபிள். இந்த சிப்ல பாருங்க, RAM மெமரியில பாருங்க. We have two signal, WE bar, OE bar. OE bar already I have told you, out from the memory location. Correct? Memory location address பண்ணதுக்கு அப்புறம் we have to select RD bar so that OE bar will be active. So out enable. So this memory will output a data through the database. WE bar means write enable. That means from the data bus, from the 8051 microcontroller, through the data bus, it is writing some data. That means write enable. Fine. So that way we are having two signals, one for read operation, the other one for write operation. So that's all about the external memory interfacing with 8051. Fine. The left-hand side diagram is for external program memory. The right-hand side diagram is for external RAM memory, external RAM access. Okay. What about the condition of EA bar here? RAM memory interfacing diagram la EA bar enna pannirukanga? Can you people see? Where it is connected? It is connected to VCC. That means EA bar equal to 1. What it means? EA bar 1 na meaning enna? EA bar 1. What it means? That means this particular configuration, in the configuration la on-chip ROM external RAM use pannirukanga. Fine. External RAM we have interfaced as EA bar equal to 1, it will access the program from on-chip ROM only. I mean program memory internal irukku, data memory external irukku. Is it clear? Yes, very good Shivakumar. இது எதுக்காக இந்த டயக்ராம் அப்படின்னு பாத்தீங்கன்னா EA bar 0 na it ensure only the external program memory access. It doesn't mean external RAM memory கண்டிப்பா யூஸ் பண்ணனும் கிடையாது. Fine. Usage of external RAM or internal RAM, it depends upon your instruction. Whenever you want to access the data from external memory, which instruction we have to use? எந்த instruction யூஸ் பண்ணனும் சொல்லிருக்கேன்? RAM memory la irundhu content read பண்ணனும் இல்ல write பண்ணனும்னா என்ன instruction we have to use? Which instruction we have to use? I have told in the slide. Instruction, I am speaking about the instruction. This instruction, MOVX. Whenever your 8051 execute MOVX, it will try to access the data from external memory only. Clear? So, அதனால இங்க நமக்கு hardware configuration எதுவும் கிடையாது. External RAM or internal RAM decide பண்றது. Whereas in the case of program memory, you have a hardware. Fine. I hope everyone understand up to this. Shall we move further? Yes, fine. So, in a class la idhuvaraikku enna paathirukom? How the memory is organized. Fine. Then how the internal RAM memory is organized. Fine. Then we have discussed how to interface the program memory, external program memory with 8051 and external RAM memory with 8051. Fine. Now we will have some questions. The internal RAM of Intel 8051 is divided into how many areas? Dash number of areas. Internal RAM memory எத்தனை ஏரியாவா டிவைட் ஆயிருச்சு? That 128 byte, total 128 byte எத்தனை ஏரியாவா டிவைட் ஆயிருச்சு? Very good. 3 area. Yes, internal RAM is divided into 3 areas. What are the areas of internal RAM memory? What are the 3 areas? Dixon, it is not 2 area, it is 3 area. What are the 3 areas? Can you people type it in the chat? How the total 128 byte RAM is divided? Yes. Lower 32 byte. For what purpose it is allocated? Very good, Andrew Surya. Register bank area, bit addressable RAM area, and the general purpose RAM area. Slide number. How many register banks are available in Intel 8051? How many register banks are available in Intel 8051? 4. How many registers are available in each bank? Yes, very good. 8. So 4 register bank and each has 8 register from R0 to R7. Fine. What is the address range of register bank area? எதிலிருந்து எது வரைக்கும் பார்த்தோமா அந்த டயகிராம்ல? Yes, 00 to 1F. Very good. Fine. Then, what is the address range of bit address RAM area? Another 16 byte. Correct? 20 to 2F. Very good. So 20 to 2F. Which signal of Intel 82 is used to demultiplex the lower order address and data bus while accessing the external memory? Yes, very good. Very good. Yes, very good. Many of you are typing the correct answer. ALE. Which signal of 82 is used to read the data from external RAM memory? External RAM memory. Which signal of 8051 can be used to read the external RAM memory? Yes, RD bar. MOVX is an instruction, Vignesh. Actually, MOVX is an instruction. Okay. Which signal? RD bar signal. Fine. Which signal of 8051 is used to write the data to external RAM? Yes, WR bar. Fine. Now we will go with the CPU SFRs. Fine. So out of the 21 SFR, okay, we have some SFRs which are associated with the CPU. That means for general purpose, these SFRs are going to be useful for programming. Fine. So the special function register associated with the CPU are as follows: accumulator register, B register, DPH, DPL, then SP. Fine. So these are the special function registers which are associated with the CPU. First of all, you have to know what do you mean by special function register. Fine. Fine. Okay. Generally, the register bank area, 32 register, which can be used as register for general purpose operation. Okay. Whereas this particular registers, accumulator, B register, DPH, DPL, SP, it is going to have some special capability. There we studied in 8085. Like that, here it is going to have some special capability. Fine. First of all, SFR abin sonale, those registers which are mapped from address 80 to FF, that we call it as SFR. In the register la 80 to FF in the address space la map pannirukangalo, all the registers we will call it as special function register. So 21 SFR abin sonna, what it means? Those registers are mapped in the address from 80 to FF, that we call it as SFRs. Okay, those register, it is going to have some specific functionality rather than data storage. It is going to have some specific functionality that we will discuss now. Okay. Okay. A stands for accumulator register. Fine. Its byte address is E0. Fine. Its byte address is E0. Fine. Then coming to the next thing, in the particular register, accumulator register, whether we can address each bit or not, that we call it as bit addressable or not. Yes, accumulator in 8051 is bit addressable. That means each bit of accumulator you can able to set or clear. Fine. Bit addressable abdina meaning without affecting any other bit in that whole byte, you can set or clear a single bit. So accumulator is an 8-bit register, correct? Adula ido oru bit mattum na set or clear panna mudiyuma appdin kettumna, yes, it is possible. That means each bit of accumulator can be accessed separately, that we call it as bit address. Fine. So A stands for accumulator register, used to perform ALU operation. Like your 8085 microprocessor, here also accumulator is going to be used for performing arithmetic and logical operation. So one of the operand kandipa enga irukanum, accumulator level, that we will discuss later. Then coming to B register, its byte address is F0. It can also be addressed each bit. Each bit of B register can also be addressed. So it is also bit addressable register. Fine. So for what purpose B register is used? It is used to perform 8-bit multiplication and division operation. Okay. Here in 8051 microcontroller, we have dedicated instruction for performing multiplication and division operation. Whenever executing the multiplication and division operation, the other operand, fine, one of the operand kandipa accumulator level sonna, correct? Similarly, the other operand must present in B register. Fine. So B register a special function in to perform multiplication and division operation, it must be used. Fine. Then DPH, DPL. Fine. DPH, DPL. Combinedly, it is termed as DPTR, data pointer register. DPTR nu solluvom. Fine. So the higher byte is DPH, lower byte அப்படிங்கிறது DPL. So combining DPH and DPL, how many bits we can have? Combining DPH and DPL, how many bits we can have? DPH, it's an 8-bit register. DPL, it is an 8-bit register. Combining these two, how many bits we can have? 16-bit. Fine. So this two register, okay, combinedly it can be used as a data pointer register. Data pointer higher byte, data pointer lower byte, combined as 16-bit DPTR register. Fine. Physical DPTR register 16-bit கிடையாது. It is two 8-bit register. Fine. எதுக்காக DPTR register யூஸ் பண்றோம் அப்படின்னு பாத்தீங்கன்னா to point the data in external RAM. Okay, external RAM memory நம்ம access பண்ண போறோம் அப்படின்னா இதை யூஸ் பண்ணிக்கலாம். Or to get any data from internal or external ROM, we can use DPTR. Fine. In program, we will use it as DPTR, but physically it is two 8-bit register, DPH, DPL. Fine. Fine. Is it clear? Is it clear up to this? Then SP, obviously it is stack pointer register. SP stands for stack pointer register. Fine. So the byte address is 81. அதாவது உங்க ப்ரோக்ராம்ல நீங்க SP ன்னு யூஸ் பண்ணாலும் stack pointer தான், 81H அப்படின்னு யூஸ் பண்ணாலும் stack pointer தான். That means here in 8051 microcontroller, this SFRs can also be used with address. அதாவது 8085ல அக்குமுலேட்டர்னா A அப்படின்னு தான் யூஸ் பண்ணுவோம், கரெக்ட்டா? move A, B அப்படி தான் யூஸ் பண்ணுவோம். But here in 8051 microcontroller, each SFR is assigned with byte address. Instead of using this particular naming, you can go with address also. Fine. So அதுக்கு தான் இந்த பக்கத்துல இந்த அட்ரஸ்லாம் கொடுத்துருக்கோம். இதை வந்து ஸ்னாப்ஷாட் எடுத்து வச்சுக்கோங்க. No need to memorize these things. இந்த byte address memorize பண்ண வேணாம். You can refer the material. Okay. Fine. இதுல DPH, DPL, stack pointer, இது மூணு என்ன பண்ணிருக்கோம்? Whether it is bit addressable, on seeing this table you can see these three registers are not bit addressable, correct? It cannot be accessed. That means each bit in this register cannot be addressed individually, correct? Bit addressing is not possible for this three register. Why? Fine. Yes. Okay. Stack pointer generally எதுக்கு யூஸ் பண்ணுவோம்? To point the top of the stack memory. That's it. Fine. Okay. So accumulator register special function is to perform any arithmetic and logical operation. One data must present in accumulator. B register. Whenever we are going for multiplication and division operation, we must use B register. Then to access the external memory, we have to use DPTR. Fine. Then for stack memory reference, we are having the register stack pointer. Fine. So one thing I want to tell you, those SFRs whose address ends with 0 or 8, 0 or 8, SFR whose address ends with 0 or 8 are bit addressable. இதை ஞாபகம் வச்சுக்கோங்க. I have typed in the chat, kindly refer it. SFR whose address ends with 0 or 8 are bit addressable. So இங்க பார்த்தோம்னா A register இதோட address என்ன E0, correct? Address ends with 0, so definitely it is bit addressable. B register F0, it is bit addressable. Fine. There is some meaning behind that. Okay, fine. Then we will see about the accumulator register. First, we will see about the accumulator register. Fine. So the byte address of the accumulator register is E0. Fine. So உங்களோட இன்ஸ்ட்ரக்ஷன்ல நீங்க accumulatorக்கு பதிலா E0 யூஸ் பண்ணாலும் it refers to accumulator register only. Fine. Each bit of accumulator can be accessed with this letter. ACC.0, ACC.1, ACC.2, ACC.3 up to ACC.7. Any bit of accumulator can be set or reset. That's why it is termed as bit addressable SFR. Bit addressable SFR. Fine. Bit addressable meaning in each and every bit of accumulator you can access individually. You can address individually. Fine. So one of the operand ALU operation of accumulator fine. Next, result of ALU operation gets stored in accumulator. Fine. Next, for external data transfer you must use accumulator. The same special purpose here also for accumulator. So operation like swap and rotate can be carried out only in accumulator. That means register specific. Fine. So swap and rotate in the instruction, two operations we are having. Okay. The two operation can be carried out only in accumulator, not in any other register. Fine. So these are the special capability of accumulator register here in 8051. Fine. Is it clear to all of you? Accumulator register byte address E0. Fine. This bitwise na address panna. In programming la na panna ACC.0 to ACC.7 use panna. R E0, E1, E2, E3, E4, E5, E6, E7 like that we can use. Fine. So the confusion vena. Don't get confused. This byte address enavo adanodiye LSB bit address same ah. Fine. Adilende +1 like that the address will go on. E0, E1, E2, E3, E4, E5, E6, E7. Fine. All the bit of accumulator can have an address. That's why it is called as bit addressable SFR. So inge nama eludhirukadhu byte address. Whole 8 bit na use panna ponna byte address. Bit address means individual bit we can address. Adha byte address ku bit address ku ulla difference. Fine. Shall we move with B register? So A register portha varaikum like in 8085 one of the operand must present in accumulator. After ALU operation result will get stored in accumulator. Then external data transfer accumulator must be used. Fine. Then apart from that we have swap rotate operation that can be carried out only in accumulator only. Fine. Next, B register. So here B register, so whose byte address is F0, bit address F0, F1, F2, F3, F4. See, included program both can be used. B.0 indicate bit 0 of B register. B.1 indicate bit 0 of B register. Bit 1 of B register. B.0 that indicate 7th bit of B register. So in the Mari use or else you can use this bit address F0, F1. When you start writing program, you can understand what I am saying. Yes. Accumulator B register, both are bit addressable SFR. Okay, which can be accessed either as a 8-bit location or individual bit also you can access. Fine. So while performing multiplication, the multiplicand or multiplier must be in B register. Fine. While performing multiplication, the multiplicand or multiplier must be in B register. Generally multiplier. Kindly note down that. Generally multiplier. Multiplier is the yes, generally multiplier. Okay. Then after multiplication operation, so 2 8-bit data multiply panna namakku enna kedaikum one accumulator la irukku solliyaachi innoru B register la irukku solliyaachi. So after performing multiplication, what is the maximum possible size of data output you can have? When we multiply 2 8-bit data, what about the maximum possible size you can have? Multiplication oda result maximum ethana bit pogalam? Yes, 16-bit pogalam, correct? So your result will be 16-bit, which cannot be stored only in accumulator. In that case, after multiplication operation, higher byte of the result gets stored in B register, lower byte will get stored in accumulator register. Fine. Is it clear? Higher byte of the result is B register store agum, lower byte in the store agum. Lower byte of the result, where it will get stored? Accumulator. Fine. So part of the result accumulator, part of the result B register store. Similarly, during division, divide and accumulator divisor must be in B register. A register dividend numerator, B register divisor. It is mandatory. You just swap on. Fine. A into B is equal to B into A. Whether A by B equal to B by A? A by B, whether it is equal to B by A? Yes or no? Definitely no. Fine. So, the numerator, dividend must present in accumulator, divisor must be in B register. Similarly, when you divide a number by another number, what about the result you will get? ஒரு நம்பர்ல இன்னொரு நம்பரை டிவைட் பண்ணா நமக்கு என்ன ரிசல்ட் கிடைக்கும்? What we call it as? See, a number, yes, very good. Quotient, what about the other thing? What about the other thing? Remainder, very good. So after division operation, remainder will get stored in B register, quotient will get stored in accumulator register. Fine? Quotient will get stored in accumulator register, remainder mattum enga store agum? B register la store agum. Fine? So this is what the special purpose of your B register, special function of your B register. Fine? Is it clear up to this? So in a multiplication division, we have instruction. Okay, when we are performing multiplication or division operation, the other operand must be present in B register. Generally, during multiplication, multiplier must be in B register. During division, divisor must be present in B register. That's it. Is it clear now? Yes? Okay, fine. Next. DPH and DPL. Fine. So DPH is a higher byte register and DPL is a lower byte register of DPTR. Both DPH and DPL are combined together as a 16-bit register as data pointer register. Fine. Yes, DPTR. Programming la namme enna use pannuvom? DPTR appdin solluvom. Physically, it is two 8-bit register, DPH and DPL. So DPH oda address nam already paathachi, DPL oda address nam already paathachi. Fine. So this holds a 16-bit address. Generally, DPTR la enna irukanum? It must hold a 16-bit address. That address might be external data memory address. Whenever you want to access the external data memory, that memory address must be put in DPTR. Fine. Is it clear? External RAM memory are both internal or external ROM memory. ROM memory is a byte of data, which can be either internal or external. That's what we told. Program memory is 16-bit. RAM memory is 8-bit for internal RAM and 16-bit for external RAM. Fine. So the purpose of DPTR is to point to the external RAM or both internal or external. That's all. Then stack pointer register. So it is a 8-bit register used to point the top of the stack. Fine. So here also in 8051, we will be having stack pointer register to point to the top of the stack. But here the stack pointer is incrementing whenever you are pushing some data. That means here we have ascending stack. There in 8085 microprocessor we have descending stack. Here we have ascending stack. In 8051 stack memory must be initialized in internal RAM memory. Okay. Fine. That's why the stack pointer size is 8-bit. Is it possible to assign stack memory externally? Any idea? Stack pointer is a 8-bit register here, so that it can hold only 8-bit address. Is it possible to assign stack memory externally? Is there any possibility? Stack pointer size only 8-bit, whereas in 8085 microprocessor it is 16-bit. But here in 8051 microcontroller, the size of stack pointer is 8-bit only. So stack memory na assign pannana, top of the stack memory location, it must be pointed by stack pointer, correct? in general, or the stack memory in 8051 must be assigned in internal RAM only. It cannot be assigned in the external RAM. Why? What is the reason for that? See, external memory na ponana. What about the size of address line? Yes, very good, Anthony Surya. Because internal RAM memory address size 8-bit, so that it point to any memory location in the internal RAM. When going for external RAM, it is 16-bit. Fine. So we have only 8-bit stack pointer register. It cannot point to the external memory. Fine. That's the reason. Very good. Okay. When a byte of data from internal RAM or SFR is pushed into the stack pointer value gets incremented by 1. Fine? Correct? So that's why it is called as ascending stack. Now, stack data insert panna, stack pointer will get increment by 1. Whereas in 8085 it is getting decremented. When a byte of data is popped from the stack, okay, to an internal RAM or SFR, stack pointer value gets decremented by 1. Fine. So that's what we are saying, ascending stack. Stack la data insert panna, stack pointer increment ana, adu pere ascending stack. Decrement ana, adu pere descending stack. That's all. So that's all about the stack pointer. Fine. So also used to push or pop 16-bit address during call and return instruction. Fine. Generally, we can do only a byte to be pushed or popped out from the stack. During call and return instruction, it can push 16-bit address. Okay, 16-bit address push panna mudiyum during call and return instruction, like in 8085 microprocessor. Fine. But ore oru vishayam purinjikano, here we have ascending stack, there we have descending stack. Okay, here we have 8-bit stack pointer, there we have 16-bit stack pointer. Fine. So that's all about the stack pointer register. Fine. Then one more SFR I forgot to tell you. Okay, it is program status word register. Okay, PSW register. It is also associated with the CPU only. Fine. I think I have forgot to mention it in the table. Yes. Actually, after stack pointer, I have to mention PSW. Okay, I forgot to mention here. So stack pointer is PSW is also SFR associated with CPU. Okay, so it is an 8-bit register used to indicate the status of ALU operation under register bank selection. Fine. So like 8085 the flag register na thaniya irundhuchu, correct? Here in 8051, this PSW stands for program status word register. It is used to indicate the status of the ALU operation, as well as it is used for register bank selection. Fine. Like flag register, here also we have a word format. So this is the word format of PSW register. On seeing this, you can tell what about the purpose of CY? CY bit, adoda purpose enna? Carry. Whenever carry occur during the ALU operation, carry flag will get set. Fine. So carry generated from MSB during ALU operation appadina, this bit will get set, or else it will get reset. Okay, what about AC? What about AC? That we will discuss. AC, auxiliary carry. Fine. So when auxiliary carry exists, carry generated from lower nibble during ALU operation, auxiliary carry flag will get set, or it will be reset. Fine. So this is 85 la irundha flag register ulla bits martha ingiyum. Fine. Carry flag, auxiliary carry flag. Fine. The next F0. F0 is a user flag set or reset by software. That is a user flag. Say for example, user is allowed to set or clear this particular bit whenever an event happen in your program. Say for example, your program la neenga enna pannalam appdin pathina, you can do some task. Fine, you can write some program to do a task, whether that particular thing happened or not. Fine. Say for example, ஒரு LED நான் ஆன் பண்ற டைம்ல இந்த பிட்டை செட் பண்ணுவேன், ஆஃப் பண்ற டைம்ல இந்த பிட்டை ரீசெட் பண்ணுவேன். That means at any point of time you can know whether the LED is on or off. Fine. It is user defined flag. Correct. The flag எப்ப செட் ஆகணும் ரீசெட் ஆகணும்ன்றத நம்ம யூசர் தான் டிசைட் பண்றோம். Fine. At any point of time by referring this bit you can know whether the LED is on or LED is off condition. Fine. Generally we call it as user defined flag. Fine. Is it clear? Is it clear or not? Yes. In the flag on the automatically set agad. In program only user has to set or reset. Say for example, ஒரு switch வந்து ஆன் ஆயிருக்கு அப்படினா நான் என்ன பண்ணிக்கலாம்? See, whenever a thing you are doing in your program, fine, after that you can set or reset this particular bit, so that at any point of time by referring this bit you can understand what about the status of your application, whether LED is on or LED is off, that you can refer. Fine. The next two bits, RS1 and RS0, fine. Combinedly these two bits are used for register bank selection. Fine. In the ரெண்டு bit 00 இருந்தா எந்த bank select ஆயிருக்குமா? Register bank 0. Fine. If it is 01, register bank 1 will get selected. If it is 10, register bank 2 will get selected. If it is 11, register bank 3 will get selected. By default, which register bank will get selected? Already I have told you. Out of the 4 register bank 0 registers by default it will be selected. Fine. Is it clear? What about the purpose of RS1 and RS0? புரிஞ்சுதா? Yes, fine. Okay, next. Overflow. OV stands for overflow flag bit. Fine. Overflow அப்படின்றது என்ன மீன் பண்ணோம் அப்படின்னு பாத்தீங்கன்னா, whenever you are doing signed operation, if your result exceeds the limit, signed number limit, then you can say it as overflow. Fine. Simple word I can say. What about the maximum positive number and negative number you can represent with 8-bit sign number? Can you people type it in the chat? Signed 2's complement representation la, what about the maximum positive number and what about the minimum negative number you can have? Can you people type it in the chat? 8-bit sign number அப்படின்னு சொன்னோம்னா, what is the maximum possible 8-bit number you can represent? Can I type it in the chat? Bit pattern நான் type பண்ற பாருங்க. Okay, positive number na MSB என்ன இருக்கணும்? Can you people at least type that? Yes, very good Shivakumar. Just you convert it into decimal. The value decimal convert பண்ணா என்ன கிடைக்கும்? Plus 127. What about the minimum negative number you can have? Yes, 7 of in hexadecimal. Okay, in decimal it is 127. Fine. When you are operating with 2 sign number, if your result exceeds plus 127, okay, plus 127 in decimal, and minus 128 in decimal. So in the range தாண்டி எனக்கு exceed ஆனா minus 128 to plus 127 இந்த ரேஞ்சை தாண்டி போச்சுன்னா அதை நம்ம என்ன சொல்லலாம் அப்படின்னு பார்த்தீங்கன்னா overflow அப்படின்னு சொல்லுவோம். Generally overflow is used for signed arithmetic operation. Fine. During signed arithmetic, overflow occurs during ALU operation. So overflow அப்படின்னா என்ன சொல்லுவோம்? Either carry set ஆயிருக்கணும் or MSB reset ஆயிருக்கணும். Kindly note down the condition. It is like XOR operation. XOR of carry and the MSB bit of your result. Fine. So minus 128 to plus 127. The தாண்டி என்னோட value போனுச்சு அப்படின்னா, that means when I am adding 2 positive number, result எனக்கு நெகட்டிவ்ல கிடைக்கலாம். That refers to positive overflow. Similarly, when I am adding 2 negative numbers, I might have a positive number, that we call it as negative overflow. Negative or positive overflow அப்படின்னு சொல்லுவோம். Fine. So whenever performing the signed arithmetic operation if the result get overflow, that we call it as overflow. Fine. So the condition என்ன சொல்றோம், either carry set ஆயிருக்கணும் இல்லனா MSB ரெண்டுமே செட் ஆயிருந்தா அது என்னது overflow கிடையாது. Fine. So reset அப்படினா no signed arithmetic overflow occurs. That's it. Fine. Then the next one is reserved for future use. Okay, hyphen போட்டுக்கோங்க இல்லையா, this one is reserved for future use. Okay, the last bit is parity bit. It is in the reverse way. 85 la odd parity na enna, even parity na set agum. When parity flag will get set in 85 microprocessor, in the case of 8085 microprocessor, when parity flag will get set even, but here it is reverse. Odd parity na 1, even parity na 0. Okay, fine. If it is odd parity data, okay, whenever accumulator content changes with odd parity data, this will get set. Whenever accumulator content changes with even parity data, this will get reset. That's all. That's all about the PSW register. Fine. Is it clear? Is it clear up to this? On the table la PSW na mention panna marandhutten. Fine. Actually the byte address of PSW register is B0H. Kindly note down. Kindly note down, it is B0H. Byte address of PSW. Okay. Is PSW register is bit addressable? Yes or no? The byte address na soliten. Correct? Byte address is D0. The address ends with 0. So definitely it is bit addressable SFR. Fine. So each bit in the PSW register can be addressed individually. Fine. Okay. That's all about the PSW register. So in the flag register we have PSW register. Fine. Carry flag, auxiliary, then parity. Then additionally we have user defined flag. Okay. Then overflow flag bit we are having. Next, then program counter register, actually it is not SFR. Program counter register, actually it is not SFR. That means what? In the 21 SFR sonalia, they are all mapped in the address from 80 to FF. Fine. Whereas program counter is not mapped anywhere. That means program counter, it is having some special capability, but it is not a special function register in 8051. Fine. What about the function of program counter? Generally, the same thing here in 8051 also. What program counter will do? Yes, address of next instruction to be fetched. It points to the address of the next instruction to be fetched. So it is a 16-bit register and it is not mapped into the SFR address space. Fine. That's why it is not termed as SFR. So it points to the address of the next instruction by to be fetched from the program memory. Fine. That's all about the program counter register. Fine. But it is not a SFR. Yes, is it clear up to this? Is it clear up to this? Yes, fine. Okay. So in class la vandha nama enna paathukom appdin pathina memory organization, internal external எப்படி இருக்குன்னு பார்த்தோம். Then internal RAM address space எப்படி இருக்குன்னு பார்த்தோம். How it is divided into 3 area. Okay. And what are those area and its purpose. Okay. Then the upper 128 memory locations, it is mapped for SFRs. So 21 SFR la எதெல்லாம் CPU ஓட associated பார்த்தோம். Accumulator register, B register, okay, DPH and DPL register, then stack pointer register, then PSW register. Fine. Program counter register is not a SFR, but it is having additional functionality. It is having special capability, but it is not mapped under the SFR address space. Fine. Okay. Finally, with this we will stop. ALU of 8051. Okay. So here 8051 ALU can able to perform addition, subtraction, increment, decrement, multiplication and division operation. Apart from addition, subtraction, increment, decrement operation, it can also able to perform multiplication and division operation. Okay. Then it is similar to 8085. There we don't have swap instruction. 85 la and or XOR not rotate ellame irundhuchu. Fine. Here we have swap and dedicated instruction for clearing the accumulated register. Fine. Then bit operation பொறுத்த வரைக்கும் set, clear, and or not and not. Fine. So these are the operations that can be done by the ALU of 8051. So with this we will stop today's session. So ALU of 8051 அப்படின்னு போறப்ப 85 ல எல்லாத்தையும் என்ன இருக்கு அப்படின்னு பாத்தீங்கன்னா மல்டிப்ளிகேஷன் சப்ட்ராக்ஷன் இருக்கு. Similarly லாஜிக்கல் ஆபரேஷன்ல என்ன இருக்கு அப்படின்னு பார்த்தோம்னா ஸ்வாப் அண்ட் கிளியர் இருக்கு. Then bit operation we are having. We can able to set or clear a bit. Fine. Then we can perform and or not and not operation with the bit instructions. Okay. So that's all about the operation done by the ALU of 8051. Okay. So here we can stop the session.